We will now determine the local maximum and local minimum given the graph of the derivative of the function. So here we can utilize the first derivative test as I have outlined here to help us determine the points of local maximum and local minimum. So according to the first derivative test, suppose if c is a critical number of a continuous function f, then if the derivative of the function, that is f prime, changes its sign from positive to negative around c, that is exactly at c, then the function has a local maximum at x equal to c. And similarly, if the derivative function, that is f prime, changes from negative to positive at c, then the function f has a local minimum at c. If it does not change the sign, that is if f prime is either both positive or both negative, then we can say that it does not have local maximum or local minimum. So first, let's utilize this first derivative test to determine the local maximum and local minimum. First, I'm going to determine the critical points of this function. Remember that not able to write here. It's the critical point or the critical number. These are the points where the derivative is zero. So looking at the graph, we can see that at x equal to negative 2 and x equal to 1 and at x equal to 4, the derivative function is 0. So these are the critical points. So basically we have to look around these points to determine if there is a local maximum or local minimum of the function. So around x equal to negative 2, if we look at here, the derivative changes its sign from if you travel from this direction, that is when x increases around from left to right, it is changing its sign from positive, here it is positive till negative 2, and after which it becomes negative, which means it changes its sign from positive to negative. And according to the first derivative test, we see that if the derivative changes from positive to negative, then it is a local maximum at c. So you can say that at x equal to negative 2, it has a local maximum. Let me write down here. So we see that at x equals negative 2, it has a local maximum. Now let's look at this point x equal to 1. Around this point, it does not change its sign. As we can see that clearly, it is negative when coming from the left, and after the x equal to 1, it becomes still negative. It is still negative. So according to the first derivative test, it does not change its sign. In both sides, it is still negative. So you can say that there is no local maximum or local minimum around this point x equal to 1. However, if we look at the x equal to 4, clearly we can see that it changes its sign from negative when coming across from left to right to positive. So it changes from negative to positive. And as per the first derivative test, it is it has a local minimum around this point. So we can clearly see that at x equal to 4, it has a local maximum. So this answers the question. At x equal to minus 2, we have a local maximum, and at x equal to 4, there is a local minimum.